Hello everyone. So today I'm going to talk about class 9 to 10's physics book. So physics books first chapter. And also I'm talking about the physics book from like the science group and not from any other group. So the first chapter is titled as physical quantities and measurement. So let me start with a simple question. What is physics really about? Physics is the study of natural world, how things move, how energy works and how forces act. But before we understand any of that, there's one thing we absolutely need, and that is measurement. Now you might be thinking like why is measurement so important? Well, imagine I say this table is long, but that doesn't really mean anything in science. But if I say something like this table is 1.5 meters long, then that'll be more precise. So we can do calculations or whatever more precisely. So that's something everyone can understand the same way. So measurement turns simple observations into scientific facts, you can say. So that like everyone can like properly understand what you're trying to convey. So yeah now another question: what exactly are we measuring? In physics, anything that can be measured is called a physical quantity. For example, length, mass, time, and temperature. But here's something important: a physical quantity is like always two parts, a number and a unit. If I just say 10, that is incomplete. But if I say something like 10 meters or 10 inches, 10 centimeters, etc., now it becomes like actually more accurate to what I'm trying to like make you understand. In the topic of physical quantities, are they all the same? Not really, because they are divided into two main types: fundamental quantities and derived quantities. Let's start with fundamental quantities. These are the basic quantities that do not depend on anything else. You can measure them directly. So yeah, yeah. But examples include something like length, mass, time, temperature, and electric current. You can think of them as like the foundation, as the name suggests, like the base ingredients in a recipe, you can say, for example. Now, what about derived quantities? Derived quantities are made by combining fundamental quantities using formulas. And like for example, I can say speed. Speed is calculated by dividing distance by time. So it depends on two fundamental quantities, length and time. This is like how physics builds step by step. So you gotta first learn the basics and all, then you can go on to the more complex problems, you can say, or ideas. Let me ask another question: how do we make sure that everyone measures things the same way? For that, we use standard units. And the most important system is the International System of Units, or SI units. This system is used all over the world so that scientists and students can understand each other's measurements without confusion. Some common SI units are meter for length, kilogram for mass, and second for time. These are basically the only ones you'll see when you're calculating for these things. But you might have to like convert, like let's say kilometer to meter and gram to kilogram and etc. You get what I mean? But the things I just said, they're the main ones to like unit it properly. So like if you don't use your like proper units, your answer can be completely wrong, even if your calculation is like probably correct. Now let's think about how we actually measure things. We use different instruments, depending on what we are measuring. For example, a ruler or measuring tape for let's say length, balance for mass, and a stopwatch for time, etc. But here's something interesting. Even with proper instruments, measurements are not always perfect. So the next question is, why do errors happen? Errors in measurement can occur for many different reasons. There are mainly two types. First, systematic errors. These happen when there is problem with the instrument itself. For example, if a scale is broken, then it'll always give wrong readings and all. But the second one, random errors. These happen due to human mistakes or small vibration or variations. For example, not reading the scale properly, or some like that. And so, can we remove the errors we make? Not really, but we can reduce them. We can take multiple measurements and calculate an average, and we can also use more precise instruments and be more careful while measuring. So, yeah. Now, another question, what about really big or really small numbers? In physics, we deal with values that are extremely large or tiny. By writing them fully, can be confusing. So we use prefixes. For example, kilo means 1,000, milli means like 0.001. So yeah, instead of typing 1,000 meters, we can simply say 1 kilometer. That makes calculation and communication much easier. But depending on the calculation, you might have to stick with 1,000 meters, but that isn't consistent. So yeah, we use short forms. So what's the main idea of this whole chapter? It's not just about measuring things, it's about learning how to be precise, accurate, and consistent. Physics is not based on guesses, it's based on exact values and proper methods. So yeah, if I understand physical quantities, units, and measurements properly, I'm basically building the foundation for all of physics. That's why it's placed at the first of the book. So yeah, that was it for today's video. I talked about the first chapter of physics, and yeah, that was a short thing. And yeah, that's all for today. Thank you for listening to me.